followers. If you're viewing on YouTube, please don't forget to press like and subscribe, press the notification bell, and press that share button to share with your friends on social media. We've barely begun creating content, so get it on the ground level. Leave us a comment, tell your friends, your foes, your science noobs and science pros. We're also on BitChute, bitshoot.com/smAsho. And if you're on the channel because you saw one of our business cards, please leave us a comment. As we've changed our marketing and will continue to change our marketing, in the realm of marketing, if your marketing is remaining the same, you're failing. Let's do a cosmology segment. And this one is going to include a teaser about precession. Yes, we're about to create a pretty in-depth video here about precession and an explanation of a mystery in the realm of cosmology. So precession is the axial wobble of a rotating object, and in space, everything precesses. Really, every rotating body precesses, period. And that axial wobble does all kinds of interesting things, like, for example, changes the Earth's celestial pole star. The Earth has several different celestial pole stars throughout its precessional wobble cycle, which is about 24,000 years. And, for example, Deneb, Aldebaran, and Polaris are examples of celestial pole stars. And with respect to the Earth's precessional wobble, that green rod you see sticking out of the top of that virtual top there would be the Earth's celestial pole, and the star at which that points would be the Earth's celestial pole star. All the stars in the sky would rotate around that star from your perspective, and right now it's Polaris. In about 12,000 years, it'll be Deneb. Enough about that, and we're not going to do any random objects today. I accidentally clicked on this object, a low-mass X-ray binary / black hole. I'll refer to it as a massive radio source, V404 Cygni. So this one is interesting in that it had one massive outburst back in 2015. Since then, not so much. Here's some imagery of it. This is the 16-year chart. Here's the 2-day chart. And here's the 30-day chart of the X-ray outputs from V404 Cygni. And we'll show you this real quick on a couple different wavelengths on Aladdin Light. You can link directly to all that stuff from the Neil Gorell Swift-Bat X-ray Observatory. And there it is in infrared. Here it is in optical light from Pan-STARRS. Pretty good resolution there. You can actually see both components of the low-mass binary, it looks like. And last but not least, we'll show you on the Chandra. There it is in the Chandra X-ray telescope. Possibility of some jets coming out of that, perhaps out of one of the components of that X-ray binary. Again, that's V404 Cygni, which happens to be entry number 936 on the Neil Gorell Swift-Bat X-ray Observatory, the low-mass X-ray binary massive radio source referred to by some as a black hole. Follow your favorite transients there in the X-ray spectrum. Let's talk about this Old Faithful galaxy. Here's an image of it. And what is going on with that? That galaxy is super interesting in that it exhibits a multi-wavelength outburst every 114 days. How does it do that? Well, there are 3 possible scenarios as to how it does that. And the possible scenarios are interactions between 2 disks. In other words, there could be 2, quote, supermassive black holes, and, quote, rotating around the core. There could be a star passing on an inclined orbit through the disk of ionized gas close to the galactic core, or a tidal disruption event, which I think is actually the least likely because of the similarity to all of these bursts. So you can see how similar each burst is. If it was a tidal disruption event, you would expect to see maybe a decreasing amount of brightness for each burst or something like that as a star being, quote, tidally disrupted and, quote, loses mass. But in any case, if you want to read the paper about this one, it's located at SciTech Daily. Headline, NASA investigates old faithful galaxy that erupts every 114 days. And another interesting fact about this is we'll be able to see additional information coming out about this one in April and August of this year. So I'll just let the article scroll here. You can read it if you like. Feel free to pause the video at any time. The beauty of video on demand is that we'll be here when you press unpause. So this was discovered by actually an automated supernova project called the Assassin, the Automated Supernova Survey. And again, that article is on SciTech Daily. That's today's Cosmology segment. Let's get back to more local